So in this video we're going to look at Pythagoras' theorem. Pythagoras was a Greek mathematician that lived thousands of years ago, and he discovered a way of how we find a missing side in a right angle triangle, provided that we know the other two sides. Okay, so as stated here, Pythagoras' theorem, it applies to right angle triangles. It is used to find a missing side of a triangle, provided we know the other two sides. And what we're going to look at first is how we identify what's known as the longest side, and is given a special name, the hypotenuse. Okay, so the hypotenuse is quite simply the longest side in a right angle triangle, and an easy way of remembering that is that it is always opposite the right angle. Okay, so in any of these three triangles, doesn't matter about the orientation, what way they're turned, or what side they're sitting on, you can tell just by looking at it. The hypotenuse is always facing the right angle. I like to think of the right angle, and a right angle is normally marked with a wee square like this, as this corner is pointing and telling us where the hypotenuse actually is. Okay, and you can see it is the case with all three of these, and in fact with any right angle triangle. So identifying the hypotenuse is important in tackling any Pythagoras theorem style question. Okay, we're going to look at an example here, an example where we're being asked to find the hypotenuse, and I'll explain the information that we're given. I'm going to show you two different ways to attempt this type of question, one using the Pythagoras theorem formula and the other with these 4 steps. Okay, and it's totally up to you what method you prefer. I prefer just using the 4 steps rather than the formula. Okay, so find the missing side x, and it will normally say not drawn accurately, and that's just important to remember. Okay, when it says that a shape is not drawn accurately, it simply means that we've been asked to find this missing side x. It just means we can't simply go take a ruler and measure the side and write an answer down in that way. They're expecting us therefore to use Pythagoras' theorem. Okay, so this a squared plus b squared equals c squared is the formula for Pythagoras' theorem. You may have been taught it in a slightly different way with different letters, x squared plus y squared equals z squared, for example, but it will generally take this form, and you use whatever you're most comfortable with. In the way that I've written it, A, B, and C represent the 3 sides of the triangle, okay? And C is the hypotenuse. Now, this is the one that's important. When you're tackling any question involving Pythagoras' theorem, the first and most important thing to do is to identify the hypotenuse. So here's our triangle, here's our right angle, and our right angle is important to the hypotenuse. The hypotenuse is the side we're trying to find, the side that is labelled x. So in terms of the formula, that is C, okay? A and B are the 2 shorter sides, and I will just explain this. I've labelled this side the 3 centimetre side A and the 4 centimetre side B, and it's not really that important if you were to label them the other way around. If you were to call the 4 centimetre side A or the 3 centimetre side B, as long as we've labelled the hypotenuse correctly, it doesn't matter what sides we label A and B. So after that, you then substitute in your values to the formula. So A is the 3 centimetre side, so a squared becomes 3 squared. B is the 4 centimetre side, so b squared becomes 4 squared. And lastly, c squared is this side x squared that we're trying to find. Really doesn't matter if you were to leave it as c squared or call it x squared, because that's going to be the unknown that we find. Okay, so working our way through the formula now that we've substituted everything in. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. And we're adding these two. I do it line by line, setting my working out nice and neatly. 9 plus 16 is 25, which equals x squared. And the most important thing to remember when you're attempting a Pythagoras theorem question is that we're not looking for x squared, we're looking for x. And the opposite of squaring something is square rooting it. So we're not interested in x squared, we're interested in x. So what we have to do is work backwards and square root 25, and always remember the square root at the end of a Pythagoras theorem question. Okay, now when it's a question like this where we have a nice square number, you should know that the square root of 25 is in fact 5, and always remember units. So we're working in centimeters, therefore our answer here will be in centimeters, and that's important because sometimes there can be a mark for stating the unit of our answer. Okay, if it's a case, which we'll see later on, where we have to use a calculator, I'll show you where the square root button is on the calculator. And it's important that with your own calculator, you are fully aware of where it is. It might look slightly different than my one, for example. All right. Now, generally the way I prefer doing it is following these 4 steps. I don't particularly like using formulas or substitution, and that's fine. So I will do it this way. So the first thing is I identify the hypotenuse. So in terms of this triangle, the hypotenuse is x, okay? After that, square the known sides. So 3 squared and 4 squared. 3 squared is 9, 4 squared is 16. So square both sides, we add them, which is 25. And then the last step is to square root of 25 is 5 centimeters. Generally, the reason I prefer this method is, for me, it's just keeping these 4 steps in my head just helps me to work through the question much quicker. Okay, and if that's the way you prefer doing it, do it that way. And this is generally how I'm going to stick doing these questions from here on out. All right, and just to show you with a second example, okay, again, we're sticking with finding the hypotenuse. And again, just another way which the question might be worded. In the last example, you saw that they called the missing side x and give it a letter. Sometimes they might label the sides, it's the corners of the triangle they've labelled. So here we see a triangle where the corners have been labelled A, B and C, and they've asked us to find the length AB. Again, the triangle is not drawn to scale, so we can't just use a ruler to measure it. So if I'm finding the length AB, AB is from A to B, so it's quite clearly this side here. And this side here, as we can see, is opposite the hypotenuse. So it's the hypotenuse we're trying to find. So when we're trying to find the hypotenuse, we're following these steps again. Okay, so we've identified the hypotenuse. We're now going to square the known sides. So I'm squaring 6, I'm doing 6 squared, and I'm squaring 3 squared. 6 squared is 36, 3 squared is 9. I'm adding, which again, as you can see, is my next step. 36 plus 9 is 45. And the last thing I need to do is square root 45. Now, 45 is not a square number. So in this case, I'll need to use my calculator, okay? So this button here is my square root button. Again, it might look slightly different on your own calculator, but that is a square root symbol. So I'm square rooting 45, okay? How this works, I hit square root first, and I type in 45, and I hit equals. Now, you'll see I've got a big long answer. You'll often be asked in a question like this to round to a suitable degree of accuracy. I'm going to round this to 2 decimal places. So that means after the 0, I'm going to cut these numbers off. And because this is an 8, the 0 will round up to a 1. So my answer is 6.71. And again, my units, centimeters. I will cover rounding to decimal places or significant figures in a separate video. But again, it's just something to be aware of, that in some of these questions with Pythagoras' theorem, you may be asked to round to a suitable degree of accuracy. Okay? So, aside from that rounding at the end, you can see the question very much the same set of steps. Now, the next thing we are going to look at is how we find a shorter side. Okay? There's only one real difference here. Okay? So, there was my 4 steps for finding the hypotenuse. So identify the hypotenuse, square the known sides, add, and then square root. As you can see, the steps are almost identical except for this one. So instead of adding, we're just going to subtract. Okay, so let's look at this. So first thing, identifying the sides. So here's my right angle, and there is my hypotenuse facing it. Now, I'm given the hypotenuse, that's how I know I'm finding the shorter side. And you can even tell, even though it's a diagram that's not drawn to scale, that this is a shorter side. So we're finding a shorter side, okay? The next step is the same, square the known sides. So I'm doing 13 squared and 12 squared. 13 squared is 169, 12 squared is 144. And this is the only bit that's different, is when we're finding a shorter side, we have to subtract instead of add, okay? 169 take away 144 is 25. And again, 25 is a nice round square number. So I should know that the square root of 25 is in fact 5. And again, the units of my answer in this case, sorry, that was my mistake, that should say millimeters there as well, is millimeters. So I make sure that in this case it's millimeters. Okay, so not much of a difference when we're finding a hypotenuse or finding a shorter side. So just remember, if we're finding a hypotenuse, we add after we square the numbers. If we're finding a shorter side, we subtract after we square the numbers. I'll put some questions for you to try, and any issues at all, make sure to ask. The next lesson we will look at questions where we try applying Pythagoras' theorem to shapes such as rectangles or isosceles triangles. But again, what we will do now is identifying a right angle triangle within those, and then of course situations such as where we might see a ladder against the wall and how that can form a right angle triangle. So there's more on this topic to come.